Mathematics describes everything we see, everything we cannot see, and everything we assume. It can be applied in a wide variety of areas, from determining the amount of thrust needed for a rocket to exit the atmosphere to the flight path of a baseball. The general basis of mathematics is often left without any sort of ethical check system because the concepts considered, like rocket science and the flight path of a baseball, are too limited to create concern for the outcome. But in the concept of the AI, the mathematical spectrum is significantly extended by the use and creation of simulations to predict the present or future. Clearly, a real-life situation or simulation with enough detail to accurately resemble and recreate the world in which we live today would change the way the world in which today works and bring with it a boatload of ethical and legal concerns. The topic of discussion for this today will be the specific ethical impacts on mathematical operations, starting with how are unethical practices such as data dredging used by statisticians to deliberately manipulate and mislead people. So when considering mathematics, it must be evaluated as to how the brain functions, because the ethical aspects of mathematics comes from the interaction with humans. Apophenia is the perception of connections or patterns in information, even when they may not exist. Pareidolia is the seeing or hearing of things that weren't often meant to be there. Humans naturally have a strong sense for this. A few examples are the face in the moon. This face in the moon may look like a face, but it is not a real human face. Yet when you look at the moon and you look at this image, the first thing to pop out at you is going to be the face that's so clearly imprinted on the moon. Another one is some general household appliances like this cheese grater. It looks like a face. It's instantly you recognize it as a smiling face. And same with this outlet. Some people will see the outlet and they see almost a shocked face, which is kind of funny. And it's also considered that if you draw a face on something, like you make it more personalized or humanized, then you're less likely to lose it and you'll be more attached to it in terms of knowing where it is and understanding where you last put it because you'll be more attentive to the details of the object. So the brain is naturally attentive to these patterns and faces. It's always looking for the danger and is a naturally evolutionary trait. In any ambiguity, the brain will decide danger before it decides safety. It will always assume something's dangerous versus it's safe. This same bias applies to whatever we want and whatever we're looking at. There's also a selection confirmation bias, and then there's the law of near enough. So two things in comparison just have to be somewhat similar in order for them to be associated. Hence, they just have to be near enough to draw the connection. They don't have to be directly linked. This is the same way in which psychics work their magic on people. You can just make a very general statement about someone's future, and so long as it's near enough to the realistic outcome, which based on the generally designed statements that they'll give, it will consistently be near enough, then you'll associate it with a genuine prediction. So data dredging, it can be used by statisticians to deliberately manipulate and mislead people, and it can be unintentionally done by every single person. So if you're going to data dredge, you're going to understand that humans will see these patterns and they'll always be looking for patterns naturally through the brain, and you can change the data or manipulate the data and so that the first pattern seen is one that you desire. Or you can unintentionally manipulate the data as a statistician, whatever it is, by looking for the patterns and forming a hypothesis as you're working towards something. So songs will have a likelihood to link up with another motion picture film because as humans, we all use similar rhythms and beats that we like, not just because they have some sort of conspiracy behind them. That same concept can be applied to the data, considering that the information will be based off of humans, and therefore intense similarity would play out between simulations. So an example of, I guess, pareidolia is this video. So if you look at Brainstorm, you're going to hear Brainstorm. If you look at Green Needle, you're going to hear Green Needle when it plays. And I know it's spelled wrong here, but it's whatever. Another great example is the Space Odyssey, which so perfectly lines up with the music of Pink Floyd's Time. So it's interesting to see this. So these are real examples of how this will naturally line up with what we're looking at. We find patterns in everything, and Space Odyssey was never intentionally working with Pink Floyd to make the song line up, yet it does, and yet you could recognize it, and I can recognize it, and same with the Brainstorm of Green Needle. So another idea to question is, are mathematicians the best people to create codes of ethics for personal or professional mathematicians? So this is a good example, is that another flaw for the potential for data analysis on a very large scale of simulation is the recognition of too many variables in the evaluation of chance. So sure, there may be several different options, but it is likely that the rock will roll down. And just because that option for how the rock rolls down is 1 in a million, doesn't mean it is particularly special because it is going to roll down. So generally in the idea, it's going to do one thing. Doesn't matter about the very, very slight differences in that. Using these statistical errors, mathematicians can wrongly interpret the results of data to showcase some sort of rare event. So it might be a 1 in a million roll, even though that 1 in a million roll is basically no different than anything else. And it's not exactly rare either. So David J. Hand is a good example of a mathematician who is examining these scenarios. So he calls this a probability lever, and he considers it what may be rare on average is in consideration of all scenarios, may be less rare in specific scenarios. So the chance of being struck by lightning is actually unbelievable because on the average, most people are not outside, and most people are not outside during storms or any sort of thunder or whatever. But for someone who's consistently outside during storms and is an avid adventurer or whatever, the chances are not even similar. So the chance of someone being struck multiple times by lightning as someone who's an avid outdoorist is much different than the chance of someone who's just an average Joe and the complex situation of their life isn't evaluated. So there's also the law of truly large numbers. So when considering the chances of something extremely rare, these statistics change dramatically when the numbers of opportunities are applied. So considering that lightning strikes Earth about 100 times a second, there are billions of people on Earth, and history has been recorded for thousands of years, it is not that surprising that someone has been struck by lightning 3 times like Walter Summerford, especially considering that Walter Summerford was someone who was consistently outdoors and an avid outdoorist. So considering these like the law of truly large numbers, how there's a consistent amount of events happening, then it is not that rare when there's millions of events happening for something that's 1 in a million, because at least one of them is going to be that way. So Littlewood's law is a perfect example of how this can be summed up. So if every event is expected to take about a second, then the chance of something happening is 1 in a million about every 35 days. So he broke it down into an event takes about 1 second. So every single second, and then it should have a 1 in a million event happening about every 35 days. There should be at least one in a million event. This brings us to the final question of mathematics is, if mathematical knowledge is highly valued, does this place special ethical responsibilities on mathematicians when they are making claims? So the perfect situation to examine this is for Sally Clark. Sally Clark was a woman who was arrested for murdering her children despite not actually having murdered her or not having proper evidence to showcase that she did so. So on February 23rd, 1998, Sally and Steve Clark, her husband, were arrested after their infant son was found dead a month prior. They claimed that he had naturally died of sudden infant death syndrome. The baby had a cracked rib, which the parents claimed was from resuscitation attempts. The mathematics issue comes along because nearly the exact same thing had happened to their other infant son nearly a year before. This is where the case took a wrong turn, as Roy Meadows used improper mathematical calculations to predict that the chances of this happening were so low that it made murder more probable, or it made double infanticide more probable. Meadows was a leading expert in child abuse and child-related like pediatrics, and his opinion was extremely valuable. So when Meadows calculated the odds, or the mother's odds of having sudden infant death syndrome, given her circumstance, to be 1 in 8,543, he took a wrong turn when he forgot to consider conditional probability. So instead of shifting the number values to reflect the event happening more than once, to consider her being disadvantaged towards sudden infant death syndrome, he simply multiplied 1 over 8,543 times or against 1 over 8,543, which gave her about a 1 in 73 million chance of having this happen. So instead of considering humans to be a complex system of different impacts, Mr. Meadows treated the two infant deaths as independent events, falling for the prosecutor's fallacy in which he declared that it is statistically likely the defendant to have committed the crime, which later on would be debunked because it is much less likely that she would have committed double infanticide than have this happen twice. And essentially, in the case, he presented this evidence as some sort of overwhelming statistical report that she had to have killed her children because it was just too rare for her to have sudden infant death syndrome. The jury would end up ruling 10-2 against her and sentencing her to jail before she could make an appeal, and with proper evidence was able to secure her spot out of jail, which took like a few years. But it shows how mathematical knowledge was highly valued. So the jury saw the chances of this happening and completely took it as a reasonable, beyond the doubt evidence that she had to have committed the crime. So this forces special ethical responsibilities on mathematicians because the way the evidence was presented was not completely realistic, because a 1 in 73 million chance sounds like overbearing evidence towards the defendant having committed the crime, but it doesn't exactly compare to the law of large numbers, with there being millions and millions of other things happening at the same time. There's a lot of different things that have an extremely rare impact, but that rare impact happens every single day. And that is all we're going to get through.